Good afternoon, everyone. So today, how are you? How was your celebration of the festival? The name of the festival is Pongal, I think. How it was? I hope everything was good. You have enjoyed the festival. In some regions, it is celebrated as Pongal. In some other, it is celebrated as Lohri, and in some other, it is celebrated as Sankranti. So I hope you enjoyed. So पतंग वगैरह भी उड़ाई जाती है ना शायद कहीं कहीं किसी किसी रीजन में लेट मी नो if it's the case in your region. Okay. So now today what we are going to study, we will start the second lecture of properties of solid. In the previous lecture, what we have studied that you should know actually, we have completed, I will say, main thing was what is elasticity, what is stress, what is strain, what are the types of strain. That's all we have discussed in the previous class. Now in this class, we will start our discussion with the Hooke's law. So what is Hooke's law? It's not the Hooke's law that we have studied in case of spring. This is a different thing actually. So let's start our discussion. What is Hooke's law? The statement of Hooke's law suggests that if the deformation produced when we apply a force on a body, for example, this is a body, and if we are applying force on it like this in this direction, then if the deformation is very small, only in that case, the stress produced in this body is directly proportional to the strain. I think the statement is clear. What is the statement? For small deformations, the stress is directly proportional to the corresponding strain. So what is the meaning of corresponding here? What is the meaning of corresponding strain? If the stress is, I say, longitudinal stress, then this longitudinal stress will be directly proportional to the longitudinal strain. If the stress is volumetric stress, then it will be directly proportional to the volumetric strain. That's what the case here. I hope the thing is clear. So what is the Hooke's law? For small deformations, the stress is directly proportional to the corresponding strain. What if I say, I can write one thing to be noticed, these all things are for small deformations. So I'm writing stress is directly proportional to the strain. If deformations are small, or you can say within elastic limit. Now again, if I move further, stress is directly proportional to strain. If I remove this proportionality sign, there will be a constant. So what I'm saying, if I write stress over strain, there will be a constant is a constant. So what we have learned, the ratio of stress over strain is a constant up to a certain limit or within elastic limit, or you can say for small deformations. This is true. And this constant is called as modulus of elasticity. Modulus of elasticity. Or sometimes coefficient of elasticity. This constant has different names depending on the nature of stress and strain. I think the point is clear. Generally, this ratio is called as modulus of elasticity. If the stress and strain for various stress and strains, this name will change. Thing is same. It will remain modulus of elasticity, but in sometimes I will call it young modulus of elasticity. Sometimes I will call it bulk modulus. Sometimes I will call it modulus of rigidity. So its name will change. So this constant, one more thing, this constant depends on the material. This is the main thing. This constant doesn't depend on the applied force or whatever may be the conditions, but only depends on the material. So this is the property of material. This is the property of material. I think till now everything is clear. So what we have learned, what Hooks say, according to Hooks, the stress is directly proportional to the strain to a certain limit, and that limit is elastic limit. After that, things will change. We will discuss it later. So now the ratio of stress over strain is a constant, and this constant is known as modulus of elasticity. Clear? And this modulus of elasticity or this constant doesn't depend on the stress and strain, only depends on the material. I think till now everything is clear. So now moving further. What I have told you that depending on the nature of stress, this constant will be named. So now on the next slide, we are naming it Young modulus of elasticity. What is Young's modulus of elasticity? If the stress and strain are longitudinal in nature, what I'm saying, if the stress and strain are longitudinal in nature, then this constant is known as Young modulus. I think it is clear. What I'm saying, the ratio of longitudinal stress to the longitudinal strain is called Young modulus. Young modulus of elasticity, it is denoted by Y. I think so you can easily write what is Y. You can easily write Y as longitudinal stress divided by longitudinal strain. Now consider a situation like this. Like this is a rod of cross-sectional area A, length L, and a force F is applied on it to produce the stress in it. And due to this force, the length of the rod changes and it becomes something elongated like this. So now its length has become L plus delta L. So what is the Young modulus will be? You need to calculate longitudinal stress to the longitudinal strain. I can easily write it as Y is equals to, what is longitudinal stress? In the previous class, we have studied that stress is equals to force per unit area. So force applied is F, area is A. So stress can be written as force per unit area. This is stress. Now divided by strain. Strain is what? Change in length over original length. Change in length is what? Delta L. Original length is what? L. So that is delta L by L. Or you can say Y is equals to this L will be transferred FL divided by A delta L. Most of you are late in the class. JNV Daman, Silvasa, PKD2, JNV Palakkar, every one of you are late. Okay. So what is Young modulus? You can remember this formula. Y is equals to FL over A delta L. What are the meaning of these terms? F is the force applied, or you can say restoring force in equilibrium. L is the original length. A is the cross section area. Delta L is the change in the length. I think each and every word has the common meaning actually, so you don't need to worry about anything. One more thing that you can remember from here: what will be the unit of Young modulus? What will be the unit? Can anyone tell? It is stress over strain. In the previous lecture, what we have studied that strain has no unit. It has no unit. And what is the unit of stress? Stress is what? Force per unit area. That is Newton per meter square. So unit of Y is Newton per meter square. Unit of Y is Newton per meter square. What we have studied till now is one slide that we have studied on the previous slide. I will show it to you. We have studied about Hooke's law. It's on your screen. What we have studied in this Hooke's law, for small deformations, yani up to a certain limit, up to elastic limit, the stress is directly proportional to the strain. And the ratio of stress over strain is constant. This constant is known as, I will slow it down. This constant is known as coefficient of elasticity or modulus of elasticity. And this constant depends on the material, not on the applied stress. Not on the applied stress. These are the things. And depending on the nature of stress or the type of stress, this constant is named as Young modulus, bulk modulus, and modulus of rigidity. So it depends on the type of stress. I think everything is sorted now. This was the Young modulus. I think now we should do some questions here. Let's take a question. I will give you 1 minute of time. Try to solve it out. And please be quick and always try to solve the questions. Otherwise, the sense of the class will be useless. First of all, just read one statement at a time and then try to draw a rough diagram. After that, we can read the second statement and try to solve the question. Go one by one. First of all, I will try to draw a rough diagram here. Question says one end of a wire 2 meter long, 0.2 centimeter square in cross section. That means area is given, length original is given, is fixed in a ceiling, and a load of 4.8 kg is attached to the free end. I have a picture in mind now. What is the picture? The diagram should be something like that, that there is a ceiling and a wire. I'm not drawing. Okay, I can draw it like that. It has some radius, na? Sorry, area. This is the wire. And a load of something 4.8 kg. This is load of 4.8 kg is attached to the free end. So this is the simple idea. A wire, there is a wire like this attached to a ceiling and there is a load. Load is like this. This load is attached to it. So now find the extension of the wire. Extension of the wire means they are asking about delta L. They are asking about delta L. So what we can do? Can anyone solve the question? Young modulus is also given. G is also given. One thing is that as soon as you complete the diagram, you can say that this 4.8 kg load, it will exert a force of 48 Newton. How this force come? This is mg, nothing but mg. And g is going to be 10 meter per second square. So I have written it directly 48 Newton. So in equilibrium, the tension in the steel wire or whatever the wire it is, it will be equal to the weight of the load. So Y is equals to F L over A delta L. Is it clear to you? FL over A delta L, that's what the previous formula that we have derived in the previous slides. So Y is equals to FL over A delta L. What we need to find? We need to calculate delta L. So just calculate for delta L is equals to FL over AY. And now just place the values. Force. What is the value of force? This is the value of force, 48 Newton. I will place the values. 48. What is the length of the wire? Original length was 2 meter. This is 2 meter. Divided by area. Area is what? 0.2 centimeter square. Remember, the unit is in centimeter square. So I will convert it. 0.2 into 10 raised to the power minus 4. This is what area. Now the young modulus is what? Y is given as 2 into 10 raised to the power 11. This is Y. So everything is sorted. You can solve it easily. So if I solve it, can you see that this 2 will get cancelled out? This 2 will get cancelled out. And this 2, there will be a 0. It will be 24 240. So delta L will be 240 into 10 raised to the power. It will become 11 and minus 4. That is 7. So it will be minus 7 meter. You can write in different formats, whatever it may be. So this is the simple formula based question, nothing else. Is there any doubt or I should move further? So I'm moving further. There is one more question for you. You need to solve it as well in 1 minute. 1 minute is enough actually. So don't worry about the time. What's in the question? Again, there is a same ceiling. And the question says both the wires are identical. That means there is one wire is this and another wire is this. This is wire 1. This is wire 2. and both these wires are identical. Okay. And Young modulus and the area of cross section is given. Young modulus is this one. Area of cross section is this one. This is area of cross section. Find longitudinal strain. Find longitudinal strain. You have 1 minute of time. Okay. First of all, let's draw some everyday type of thing. This 1 kg load will exert a force of 10 Newton. Clear? And there will be a tension produced in this wire. The tension is, I say, if I am writing it W wire 2, this tension is T2 and T2. Clear? First thing we have done, we have drawn these some forces T2 and T2, and there is a 10 Newton force. Another thing, this for this 2 kg load, it will have a weight of 20. It will have a weight of 20 Newton, and there will be a tension like say T1 and T1. Clear? So second thing is the value of tension. This T2 is the force on the wire. This tension will be acting as the force on the wire. That we known as the restoring force. So that restoring force is nothing but the tension force. So what we can write, for 1 kg block, if I say this T2 is equals to the 10 Newton, T2 is equals to 10 Newton. Do you know about the laws of motion, equation of second law of motion, F is equals to ma? If you know, only then you can understand this one. Otherwise, there will be a problem in understanding these things. On the next question, you will stuck actually. So T2 is equals to 10. How we get that? If you want me to solve that as well, you are not saying anything, so I will show it to you. Actually, these two blocks are hanged by the ceiling. So they are not moving. Their acceleration is 0. So what is the equation? F is equals to mass into acceleration. This is the equation. F net is equals to ma. F net is what? There is one force in the upward direction, one force in the downward direction, taking upward as positive. So T2, downward as negative, that is 10, is equals to mass is 1 kg into acceleration is what? 0. So T2 is equals to 10 Newton. That's what we have done. On the same way, if tension force is known, that means we know the force, the force that is creating the stress in the wire. We know that force. So what we can write, Y is equals to the stress over strain. So strain is what? Stress over Y. What is stress? Stress is force per unit area. This is what stress into Y. So force is nothing but. So strain is, what is the restoring force? Restoring force is 10 Newton. So 10 divided by area is what? 0.005 centimeter square. 0.005 centimeter square will be converted to meter square by multiplying 10 to power minus 4. This is what area. And what is the value of Young modulus? Young modulus is 2 into 10 raised to power 11. Some of you might get confused with the long calculation, but this is not the case. Calculation is not that tough. It's quite easy actually. You can easily solve this. You can easily solve this. If I say strain is 10 divided by, you can see 5 into 10 raised to power minus 4 is already there. 1, 2, 3. Minus 3 is also there. So 5 into 10 raised to the power minus 7. 5 into 10 raised to the power minus 7 into 2 into 10 raised to the power 11. This 5 into 2 will be 10 and 10 will get cancelled out. So strain will be, what is this? Minus 7 and 10 raised to the power 11. Will it become 10 raised to the power plus 4? After reaching in the numerator, it will become 10 raised to the power minus 4. And what is the unit of strain? It is unitless quantity. So this is the first part that we have calculated. We have calculated strain in the wire 2. In the wire 2. This is in the wire. Now we need to calculate the strain in the wire 1. So for wire 1, if we want to calculate the strain, we need to calculate T1. So for T1, have a look at that. Can anyone tell me the value of T1? Anyone in the chat box? Write it very quickly, the value of T1. Quick, quick, quick. Just write the value of T1, nothing else. I'm not asking a lot of things from you, just asking to calculate the value of T1. And you can do that. No, you are not going to do that. I will show it to you. I am calculating the value of T1 in this box. Okay. Just have a look at that 2 kg block. How many forces are acting on 2 kg block? One is T1 in the upward direction, this T1. Another is T2 in the downward direction, and another is 20 in the downward direction. What I have told you that F net is equals to mass into acceleration. Is it clear? What is the acceleration of this 2 kg block? It is hanged from the ceiling, so it's not moving. It has zero acceleration. So F net is what? Three forces are there. Upward force is taken as positive, T1. Downward force is taken as negative, that is minus T2. And another downward force is 20, that is minus 20, is equals to 0. So T1 is equals to what? T2 plus 20. And T2 is what? 10 Newton. So T1 will be 30 Newton. So we have calculated T1. So for wire 1, if I apply strain is equals to stress over Y. What is the value of stress? Stress is what? Force per unit area. So force upon A into Y. What is the value of force? You will say 30 Newton. What is the value of area? Area is this one. This one is the area. Can you directly write it as 5 into 10 raised to power minus 7? I'm going to write it as 5 into 10 raised to the power minus 7 into Y is what? 2 into 10 raised to the power 11. Solve it, you will get the answer. Now it's your turn. Actually, solve it. Y is equals to 5 into 2, 10. 10 into 3, 3. So that will be 3 into, okay, I am writing it wrong somewhat. This is not y, this is strain. 3 into 10 raised to the power what? Minus 4. This is the answer. Again, the question looks pretty much lengthy to you because these two things are extra that we not need to calculate. These things are to be eliminated. It should be done in your mind actually. It shouldn't be written in the question. So otherwise the question is very small. There is nothing more in that. But yeah, question comes there is a bit of calculation in such type of questions. In every time there is a calculation, so you can't just escape from the calculation part. If you have any doubt in any step, you can ask. Otherwise, I am moving forward. There is one more question on your screen. This is again an important question. Try to read it out, and I will solve it after that. You have 1 minute of time. Why I'm taking lot of questions in it? Because uh, there is a very little amount of theory in this chapter. What you can say that theory is very limited, but questions came in good amount every year. At least one question is there from this chapter. So the main thing is to focus on the questions. Okay, just read it out, read it out. First of all, whenever you see such kind of diagrams, like when there is a pulley or there is a wire hanging with some load, first of all, draw some forces. First of all, draw some forces. So I will draw some forces here. You will say this will be 10, this will be 20 Newton. First of all, just confirm me whether these things you know or not. Otherwise, things will get worse actually. Just let me know whether these 10 Newton and 20 Newton, you are aware of these things. Hmm. I think, yes, you are aware. Okay. Daman, are these things clear to you now? So now there will be a tension. There will be a tension. Let's suppose tension is T. Tension is T. Now, what will you say? Will these blocks remain in equilibrium or they will move? Will these blocks remain in equilibrium or they will move in any particular direction? You will say, sir, 2 kg is heavier than the 1 kg. So this 2 kg block will come down. So you will say 2 kg block will come down. Let's suppose its acceleration is A, and this 1 kg block will definitely go in the upward direction with an acceleration A. I think it is clear. Now, if we want to calculate anything, anything means something of young modulus kind of thing, or stress or strain, then we need to calculate the tension. Tension behaves as a restoring force. So we need to calculate tension. So for that, we need to form some equations. So we need to form some equations. So I am writing the equation for 1 kg block. For 1 kg block, the equation will look like again the same thing. Upward force is taken as positive. P minus 10 is equals to mass is 1, acceleration is A. So T minus 10 is equals to A. This is our equation number 1. Again for 2 kg block, what you can write for 2 kg block, again there are two forces T and 20. T minus 20 is equals to mass is 2, acceleration is A, that is minus 2A. Why minus? Why minus? Because block is moving downward. So what we need to do? We need to calculate acceleration or tension. We need to calculate tension in this case, not the acceleration. Acceleration is not required. So to calculate the tension, we can solve these equations. Let's multiply this by 2 and add 1 and 2. 1 plus 2. You can see that this term will get cancelled out. So it will become 2t plus t, 3t is equals to, this is minus 20 and this is 20. Is it correct? That is 40. So t is equals to 40 by 3. T is what? T will behave as a restoring force. T will behave as a restoring force. Now, what should be the radius of the wire if it is not to break? And we are given with some breaking stress. That means stress is given. Now listen to me. For example, this is a wire. This is a wire. And if I apply some force on it, that after a certain point of time, if I increase the force, it may break. It may break. So that breaking stress is given. That breaking stress is given. And the force acting on it is also constant, which is 40 by 3 Newton. So what should be the radius? So what we know that stress is equals to force per unit area. Is it clear? So stress, for maximum stress, listen to me very carefully. Stress and area are reciprocal. You can say stress is equals to force. I know the value. We can place the values actually. Force upon area is pi r square. Stress. Now you can see that if stress is maximum, then radius should be minimum. Radius should be minimum. So that maximum stress is given as, how much is the value? 2 into 10 to the power 9. This is the value of maximum stress. So I will place the value 2 into 10 raised to the power 9 is equals to, what is the restoring force acting on the wire? Is 40 by 3. Again, pi r square. Pi is what? 3.14 into r square. So you can calculate r square, or you can calculate r from this whole setup. And I will tell you the r will be, whatever you can do, you can solve this. This is not my task actually. You can solve the value of r from here. The concept need to be clear in your mind. I'm not going to waste a lot of time in the calculation part. Okay. So you can calculate the value of r from here. That will be your answer. The thing is clear. Now we can move further. Now stop me if you want something else. Otherwise, I'm moving forward. Try to be attentive in the class. Okay. So now we are moving towards second type of elasticity, second type of modulus of elasticity. Again, I'm telling you, what was the modulus of elasticity? The ratio of stress over strain is known as modulus of elasticity. Clear? Now, what is bulk modulus? The ratio of volume stress to the volumetric strain is called bulk modulus. Nothing more than that. What is B? It is denoted by B. B is what? Volumetric stress to the volumetric strain. In the previous class, or you can say yesterday's class, what I have told you, what is volumetric stress? I have told you that suppose this is a body and it is acted upon by some forces like this. And if all these forces are perpendicular to it at the point of action, if these forces are perpendicular to it, then the stress produced is known as volumetric stress. What this stress will do? It will shrink the body like this. The body after some time will look like that. So there is a change in the volume. You can say if original volume is V, then final volume is decreased by some amount. Final volume is decreased by some amount. So what is volumetric stress is V is equals to stress is what? Force per unit area. Force, and let's suppose area of action is A, divided by strain is what? Change in volume, that is delta V, divided by original volume, which is V. One thing that you can notice that volume of the body is decreasing. Originally, body was larger in shape. You can see that finally body has decreased in size. That means volume is decreasing. So for that decreasing volume, I have placed a negative sign. You can further transfer these values. B is equals to FV over A delta V, where all the symbols have usual meanings. This is a very common line that you can hear. FV over A delta V. What is F? Applied force. V is the original volume. Delta V is the change in volume. A is the area. I think it is clear. Okay. So actually the time is getting over. Uh, can anyone tell me the unit of volumetric stress, unit of bulk modulus? Is there anyone who can tell me the unit of bulk modulus? Okay. So I am ending the session now. It's time up actually. Okay. Take care and keep studying. Actually, you are not responding in the chat boxes. You are not responding. I don't know whether you are getting things or not. So just try to be responsive, and it will help you out. If you are getting these things, you can respond actually. Okay. So till then, bye bye. Take care.